this video, we are going to talk about what it means for a function to be increasing, decreasing, or constant. We're first going to go over those definitions and what they mean, and then we're going to look at how we write our answer for the intervals where a function is increasing, decreasing, or constant. So starting with the definition of an increasing function, first things first, I want to note that if I were to take my pen and trace over this graph, notice that my pen is moving upward the entire time. That is what makes the function increasing. All this definition here says is that as x values get bigger, the y values get bigger. As we continue to move to the right, the graph continues to go up. Similarly, if we have a decreasing function, notice that when we trace this graph, our pen is moving downward the entire time. That is what a decreasing function means. As the x values get bigger, the y values get smaller. That's what it means for a function to be decreasing. And then finally, the last one we'll look at is what it means for a function to be constant. Notice that as I trace this graph, my pen is neither moving up nor down. It's simply moving horizontally on a flat line. That is what it means for a function to be constant. It means that as x values get bigger or smaller, the y values stay the same. The y values stay equal to each other. So that is what it means for a function to be constant. Now, when we answer our questions for where a function is increasing, decreasing, or constant, we're going to be giving intervals as our answer, a range of x values as our answer. Now, when we write that interval, we need to make sure that we are always using parentheses. We will never use brackets when we answer an interval for increasing, decreasing, or constant. We will always use parentheses for those. Jumping into the first example, I'm going to begin tracing through this graph, and I'm going to be making a note of where my pen is moving up and where my pen is moving down and where my pen is moving simply horizontally. We need to work from the left to the right all the time. We need to start from the left and work our way from the right because we're talking about x values here, and we read them the same way that we read a book, from left to right. So starting from the left, which starts all the way off from negative infinity, because notice that there is an arrow right here. So this graph does not that graph does not start at -5. It has no starting point. It goes all the way off to negative infinity. So moving from left to right, my pen is moving upward as we trace through the graph until we get to the x value of -2. So for all x values from negative infinity to -2, the graph was increasing. And I'll end that on a parenthesis. And I stopped at -2 because as we continue to trace through the graph, starting from -2, going until what looks like, is that 0? Yeah, going until about 0, the graph is constant. So on the interval -2 to 0, that graph is constant. Notice that I'm only writing x values in my interval. So even though this is happening at the y value of -1, I'm not using that y value to write my intervals. We're only giving x values here. We are answering where is the function constant. Let's continue to trace through the graph, now picking up at 0 and tracing the graph, working left to right. Now in this green part, the graph is moving downward. And that was from the x value of 0. So I'll go ahead and start writing my decreasing interval at 0, and that decreased until we got to the x value of 2. So that decreasing interval is going to end at 2, and we will use a parenthesis on that. Now we will continue tracing through the graph, starting at the x value of 2, going all the way on to positive infinity. My pen is moving up, the graph is increasing. So I'm going to union this increasing interval with the interval that started at 2 and went off to positive infinity. Looking at example 2, we're going to do the same thing. It's very important that we always work from left to right. So starting on the leftmost part of the graph and tracing our way through the right, our pen is moving downward. As we continue to trace through the graph, my pen is still moving downward. And as I continue to trace through that last piece of the graph, the pen is still moving downward. So that function was always decreasing. So it was decreasing from negative infinity to positive infinity. And I'm making sure to use infinities because these arrows here on the ends of the graph indicate that the graph does not stop. So this graph had no intervals of increasing. It was never increasing and it was never constant.